now we are going to move to some even thicker material. Is that right, Aaron?
Yeah, so in this case, we're going to do some 3/4 hot roll material. So with this particular machine, we're going to utilize the mode converter to cut through some of the thicker plate. And then in the instance on the thinner material, we'll be able to go back to just like standard cutting. The mode converter will help the laser pierce and cut through the thicker material. Kind of just a basic overview of how that operation works.
Okay.
So here we'll go same process, go into our process monitor process monitor is always where we're going to do our cutting. Program editing, we're going to do any type of editing to the program if we need to. So here, everything's good. You want to hit start. It is going to go through a nozzle changing function.
Okay.
In the cabinet here. So it's going to grab the correct nozzle for that material. In this instance, we are using our wax system, water cutting.
Yeah.
So the nozzle actually has some holes inside of it that allow a mist of water to distribute across the top of the plate.
Interesting. Yeah.
So that's going to help anneal the material a little bit. It's going to help our thicker plate. We're going to get more parts per plate because we can thin the webbing a bit between each part.
Ah, yeah, because you don't have to worry about warpage and
correct.
Stuff like
Yeah. So in the older days, it was a little harder to do multiple parts closer together because you had blowout welding. There's a lot of heat being introduced into the material. In this case, with just a little bit of water mist, we're able to kind of control that heat from spreading rapidly across the plate, so we can get more parts closer together.
I remember seeing that in the older days where that head would have to travel all the way to the other side of the sheet, and then come back and keep traversing it.
Yeah. You kind of back then you have to space it out and try to eliminate that heat from transferring from part to part.
Yep.
And Aaron brings up another good point. So the wax, and then another option with the machine, typical mid to thick materials. So the wax is standard item, and also the oil shot, which is basically a means by which to minimize spatter from getting adhered to the tip of the nozzle. That'll be standard as well.
So here we're cutting this 3/4 at about 34, 35 inches a minute in real time here. Very quick program. So this one was about 1 minute and 53 seconds for just one single part.
We take a look at the results when we're wrapping it up here?
So in order to take a look at the results, we'll do, in our utilities page, we'll do a shuttle exchange.
Okay.
So here we'll hit the utility.
Wait, before you start, okay. Should I go back there and watch the exchange?
Yeah, so if you want to go to the back over there, we can actually show the
I'll do that.
process. So if you follow me, normally an operator is going to have to confirm that his area is, there's nobody in here, the safety devices are set, there's no obstructions, and if that is the case, then we'll hit the work set ready button. Our shuttle table will move up, and then the operator will come back to the control, and then he'll utilize that change shuttle. So here you can see the shutter door opening. Going to pull the LST table out. Here we just kind of wait until it locks it into place and exchanges the top cable and place.
And probably that top shuttle table would have material on it.
Yeah,
correct?
so we would normally load both tables with materials that we're going to be using. So maybe in this case, one table we're using for remnants, other tables we're going to be using for full sheets for production.
Okay.
Or depending on the environment, if it's more job shop related, then maybe we'll do a lot of remnant materials kind of scattered across both tables.
Good.
So if we want to take a look at these parts real quick. So here is our 18 gauge mild steel that we did. So here we utilize that flash cutting ability.
Oh yeah.
A standard nitrogen etch, just for maybe like a part name or something like that. You can see.
Is that squares and circles on the vents there?
Inside here?
Yeah. Yeah.
Yeah, squares and
yeah.
circles. Yeah.
Okay.
Yeah, so you got squares on this side, circles on this side.
Gotcha.
Here are some knockouts. So you can also
Oh, wow.
program material knockouts in the laser as well. So that's kind of nice.
Oh, look
Depending
at
on
that.
if
That's
you're doing
easy.
like electrical or something of that nature,
Yeah.
you can pop those out pretty easily.
So the guys down at Cooper Beeline making those boxes,
Yep.
electrical boxes.
Exactly. So now you're able to, you know, we've been doing it for a while, but this is kind of just to show some of the solutions that the laser can provide.
Yeah.
Here you can kind of see if we pan over to the 3/4 material.
Wow, look at that.
So this was cut on this machine. You
And that
kinda
took how
see-
long, Aaron?
This was about 1 minute and 53 seconds.
Okay.
From start to finish for the single part.
Yep.
So here's our top surface. You can see
Really nice.
very
side.
clean edge.
Yeah.
You know, very easy oxidation to remove if this needs to be welded or powder coated or something in a secondary operation.
Yeah.
Very minimal to no dross buildup on the bottom as well.
But that time that you save downstream is just
Crucial.
essential. It's great.
Yeah, it is crucial. You can see some of the residual from the misting on the material. They kind of give you an idea of what it looks like
Yeah.
when you're using the wax system.
Yeah. Great.
And then here, so here we tap this in. This is our 1/4" mild steel with
Okay.
nitrogen cutting. So you can see there's a nice clean edge, very clean cut. So this would require little to no secondary operation if you were doing painting or welding, because we are cutting with nitrogen on this mid-thick material.
Yeah.
So you don't have to worry about oxidation, and you don't have to worry about any contamination for welding, because we're not using either gases that would, you know, cause contamination.
Yeah, for sure. Great. That's wonderful. Thank you. That's a wonderful intro.
No problem.